Hi there, my name is Ajipal. I am with Alex, Cindy, and Nick in Group 2 of BTS 430. We are going to present a partial system design documentation. For this assignment, we will be covering the following use cases. Customer creates a customer account, customer creates an order, shopper creates a shopper account, shopper shops and delivers an order, grocery store creates a grocery store account, grocery store add products for sale, customer requests to return products, manager approves a return request. So let's proceed to first use case. In this use case, customer will create a customer account. For this use case to be complete, customer should already be on the Konoha's gift website. And upon the successful completion of this use case, customer will be able to see a list of products so that he can add them into the order. And for this use case to be successful, customer should have a valid email address and the password he should choose should have at least one uppercase, one lowercase, one digit, and one special character. First we'll see the system sequence diagram. In this diagram, it will tell us how customer interacts with the system. First, the customer clicks for the sign up and the system will display a form. Customer will then submit the form and the system will validate the customer and display the product. In the domain class diagram, we'll see different classes and how they are linked with each other. We have customer class, cart class, product, and payment information class. The cart line product class is linked with cart class and the product class. So first, customer creates an account to display product class. The customer add products in the cart class. And for the product to be correctly added to the cart line product class will ensure that the quantity is correct. And next in the cart class, finally, the customer will add the payment information class for the pre-authorization. Next we have state diagram for the customer account. It will show us the customer account in different stages. First, the customer, when the user creates an account, it goes into the verification product. When it fits the criteria, the account is verified and is created. If it doesn't fit the criteria, it fails and it goes to the retry so that customer can retry to validate the form. Next we have object level diagram. It shows us two different objects interacting with each other. The first is user and then the account. User will create an account and the account will display a form for the account to be created. The user will submit the form and then the account will be created and the products will be displayed. The next use case we will be viewing is customer creates an order. In this use case, customer will create an order and will get a pre-charge on that order. For this use case, customer should already be logged in and viewing the product. And upon the successful completion of this use case, customer is viewing the card with the products and their quantity. The only rule that applies to this business use case is the quantity entered should be less than the quantity in the inventory, or it should be equal to it. The first is the system use sequence diagram. It shows us how system interacts with the customer. The customer first clicks on the product and the product is added to the cart. Customer confirms that product and submit the cart. System asks the payment information. Customer confirms payment information and the system saves it for the pre-auth. The domain class is same as the previous use case. Customer will add the correct quantity of product to the cart and it will get a pre-authorized for the cart. Next is the state diagram for the product. It will show us the product object in different states. When the customer clicks on the product to add it to the cart, product is first verified if the quantity is correct. If it's verified, then the product is added to the cart. If it not, then it fails and it goes to the beginning. And last we have object level sequence diagram. For this diagram, we have user, product, cart and payment information. First, user clicks on the product to add it in the cart. Product asks for the quantity and the user enters a valid quantity. The product is then added to the cart. The cart then asks for the confirmation. When the user confirms the cart, the payment information is asked. The user confirms the payment information and the cart is pre-authorized. And for the next use case, Nick will be taking over. Thank you.
Our third use case is shopper creating a shopper account. This use case enables a customer to shop for orders made by other customers. Actors: customer, who initiates the use case, and an external email system, which is an independent system. Customer must have an existing customer account. Their existing customer account will upgrade to a shopper account. To initiate the upgrade process, they should be on the shopper sign up page on our website. Some business rules include that the shopper must be legally able to work, have all the requirements for traveling, such as a car with insurance, license, and registration, provide all the required information, such as address info and banking information, own a smartphone and an insulated bag, and be able to lift moderately heavy objects by themselves. This is the system sequence diagram, which will be elaborated in the object level sequence diagram shown later. This is the domain class diagram. Note that a shopper is a customer with more authority. As mentioned previously, you are required to have a customer account to become a shopper. Not all customers will elect to become a shopper, hence the 0 to 1 relationship. During the registration process, they'll be given a test. Could be many tests associated with the registration object in the case where a shopper would fail, hence the 1 to many relationship. Upon registration, they'll be given a payment card, which is used to make purchases on behalf of customers while shopping. Shoppers also have a working zone, which specifies the area of coverage for a shopper. This is the state machine diagram. The first state is a pending state, where all the information provided gets verified. If successful, the shopper will be prompted to take a test. They will be continuously prompted to take a test until they pass. Once they pass their test, they have to wait for their payment card to arrive in the mail. Finally, once they receive, they may register the card. The next diagram is the object level sequence diagram. Note that the customer authentication and the shopper sign up parts are completed on our website. Subsequent steps after successful account creation will be held on the shopper's smartphone. As per the use case, the customer provides all the necessary information, such as banking information, working zone, and background check images. Our fourth use case is shopper shops and delivers an order. This use case enables a shopper to initiate the shopping and delivery process of a customer's requested goods from a specific grocery store of their choosing. Actors: shopper, who chooses the order to shop, customer creates the shopping request, and a cashier, which registers the payment of an order. Preconditions: the customer has created an order, which the shopper has subsequently chosen to fulfill. Postconditions: the customer receives their order and reviews the work completed by the shopper. Business rules: shoppers have a rating that is measured with 5 stars. The shopper's rating is the average of the last 50 completed orders. If the rating is below 1 star, they shall be deactivated. The shopper must ensure that the customer is in possession of the purchased goods immediately upon delivery, except for the receipt. The receipt is kept by the shopper as proof of retrieval for all the requested items. For privacy and integrity, personal information must not be shared outside the app. Additionally, the shopper must work alone. If successful, the shopper should earn 10% of the order amount after successfully delivering an order. Here is the system sequence diagram. The loop specifies when a shopper is looking for the requested items in an order. Once again, this diagram is elaborated in the object level sequence diagram. Here is the domain class diagram. When a shopper selects a shift, the system will save the assigned time. During a shift, the shopper will fulfill orders made by customers. Orders have notes that contain special instructions for the shopper when they're completing the order. The conversation and message classes facilitate a method of communication between the shopper and customer. An order has many order items, which represent the contents of the order, each described by the item class. Note that each order item has a state, which is elaborated in the state machine diagram. A customer may have a coupon to discount a particular item or an entire order. We keep track of this with the coupon and barcode classes. Moving on, this is the state machine diagram for order item. The first state is the not found state. When a shopper finds an item, they notify the system by scanning the item with their phone. Assuming it's the correct item, the shopper will be asked to input the quantity obtained. If that amount is equal to the requested amount, the item is considered complete. If a shopper is not able to find the item or correct amount of the item, they would discuss the matter with the customer and let them make a decision. The final major point of this diagram is the fact that a customer can change their mind on an item at any previously mentioned state, hence the cancel event. The next diagram is the object level sequence diagram. As per the design, order manages an order item set. The next call is set start position. If you look further down the diagram, you'll see the calls set shopper start time and set shopper end time. These are useful metrics for the system to record, as they determine the expected time the shopper should complete their work. As the order gets processed, the order changes state. Every time the order changes state, the customer is notified of progress. As previously mentioned, the loop in this use case represents when the shopper is looking for items. The logic inside the loop would involve modifying the states of each individual order item as they are being found or cancelled, exactly as mentioned in the state machine diagram. Note that after everything is found and the shopper would like to make a purchase, it's done with the payment card. Finally, after payment, they'll be prompted with delivery instructions, which include navigation instructions and special instructions. Special instructions correspond to the note object associated with an order. Thank you. Next is Alexander's use cases.
Hi, my name is Alex Samaniego, and I'll be presenting the 2 use cases that I worked on for this project. So the first one is the grocery store creates a grocery store account. So a grocery store manager can create a grocery store account to begin selling products for that store on the grocery delivery app stores. The only actor for this use case would be a grocery store manager. The precondition is that the grocery store must not be linked to an already existing grocery store account. Post conditions: the grocery store will have a grocery store account that they can log into, and the grocery store will have the option to add products to sell for customers to order to be delivered. Business rules: the information inputted by the store manager must contain valid data characters. So for example, for the phone number of the grocery store, it must only be numeric digits. Can't have characters in there. And they also must agree to the terms and service to register. The system sequence diagram for this use case: so the manager will request to create an account, and then the system will respond with a display form asking for information about the grocery store, such as business name, address, phone number, email. And then once the user will fill out that form, and then the system will reply. We'll check if any fields are invalid, and then if they are, present the terms and service agreement to the user. Then the user will agree to that service, to the terms and service, and then the system will send an email to verify the account. The email will go to the owner's email address and they can verify, and the owner will click the link in the email, and then the link will redirect the user to a confirmation page confirming account verification, and then the account information will be sent to the delivery service for approval. And once approved, the options to add products will be available and displayed. And going back to this slide, the alternate flows for this system would be if a grocery store already if the grocery store has already been added to the system, then it will redirect to the login screen for the appropriate, so then they can log into the appropriate account. If the user inputs invalid characters, it will erase all fields and ask the user to input the data again. And if the account cannot be verified or approved, the store will not be able to add products until the account is verified and approved. And then the domain class, the what we're focusing on here is the left side of the diagram. So the grocery store will be linked to only one seller account, and the seller account will be linked to only one grocery store. The grocery store will have attributes for the store name, the phone number, email, and then address of type address, which is right here. And the address has street number, street name, city, province, postal code, and country. And grocery store can only be located at one address, and that address can only have one grocery store at it. And the grocery store is also linked to one owner, and that owner can only own this grocery store. And then the manager who can sign into the grocery store account, he's linked to the grocery store, and the grocery store can have many managers, so it's one or many, and the manager only manages one grocery store. Next, this is a state diagram for the seller account right here. And so once a seller account is created, it's not linked to any grocery store. And then once it gets linked to a grocery store, it's not yet verified. So then it can either be successfully verified, or the user can not accept the terms and service, in which case the grocery store account or the seller account will be deleted. And if a seller account is already linked to a grocery store, it will also be deleted. Then once it's successfully verified, the seller account will be linked to a grocery store and verified. And it's verified, and it still needs to be approved. So if it's not approved, the seller account will be deleted. If it is approved, the grocery store is verified and approved, and seller account is okay to add products. So once it adds products, the products are linked to a seller account, and then they can keep adding more products as needed. And then grocery store is verified and approved, and if they want to unlink the grocery store, the seller account will be deleted. So this is the object level sequence diagram. So once a manager requests to create an account, he will pass through the username and password. Username and password will go to the manager account control. And then that control will create a seller account and initialize the username and password. And then this control will get the username from the seller account, and then it will also persist the seller account, so then it saves into the entity manager. And then it will display the username and grocery store input fields. The user will then add all the store information. It'll add all the store information for the store and link it to the seller account. And that seller account will create a grocery store object, and initialize all its attributes with the input information. Then the system will send a verification email, and then once you verify the account, the system will make the store persist into the entity manager. So the next use case is a grocery store adds products for sale. So a manager from a local grocery store can add items from their store to be available to customers, and the system saves this info to the product listings. And the only actor again is a grocery store manager. The precondition is that the store account must have been approved by the delivery service company, and the post condition is that the product should have a name, price, inventory count, and description. The only business rule is that, again, the information inputted by the store manager must contain valid data and characters. This is the system sequence diagram. So again, the store manager will log in, the system will validate validate credentials and authenticate the user. And then the manager will select items. Will select add items to product listings. So they'll add items, and then the system will reply with a input form. The system will So the user will select to add items, and then the system will respond with all the items currently in the product listings, and then they'll select add new item, and then it'll reply with it'll display all the input fields, and then the user will enter product information. Then the system will ask to confirm, and once it's confirmed, it'll save it to the database. And so the right side of the diagram is what we're looking at here. And so product listings, all products are linked to only one seller account, and a seller account can have many product listings. Can have 0 or many product listings. And then each product listing has a category, and then the category can have one or many products. But a product can only be linked to one category, and a category can only be linked to one product listing. And so this is for the product class right here. This is the state diagram for it. And so a product's created, there's nothing in there, null attributes. So if a user enters and it's invalid, it'll ask to re-enter again. Otherwise, the user can cancel. Then this object is deleted. And if valid attributes are inputted, then the product is added to the database, and then the user can edit the info in this object. And if the product is removed, the object gets deleted. And so this is the object level sequence diagram. So the user will add products. It'll input all the product information, and then the manage products control will create an instance of a product listings with all the product info in it, and then it'll also create a set of categories. And then the product that the user wants to add will be added to all the products in this set right here. So each category will create a set of products, and then what the user inputted will be initialized in the products. And so the manage products control will get all product info, and then the category will also get all product info. It'll call functions from this product class in order to display all the product information. And then once the user confirms, it'll persist into the manage products control will persist all the products into the entity manager. And so next, and that's it for my two use cases. And next it will be Cindy presenting her use cases for returning products in the system.
Let me discuss use case 7 first. This covers a scenario when a customer submits a request to return an eligible item. The actor is the customer. We have certain preconditions like the system being active, the customer has an account already and knows the order number that contains the items to be returned. The expected post conditions are that the customer is able to submit a return request and receive an email confirmation. Some of the business rules for this use case are that the customer must submit the return within 7 days of receiving the order, and the items need to be eligible based on the store's return policy. First, let's look at the system sequence diagram. We can see the interactions between the customer and the system. The customer has to log in, so we have an authenticate action to the system. If the credentials are valid, the system returns the order. Then, the customer selects the order and other information is returned. We finish with a loop where the customer starts a return request for each item. Second, we have the domain class diagram. For this use case, we can simply focus on that part. The return request has a return request line item in a composition relationship. Each request line item is created based on the items in the original order. For the state diagram, I have chosen to model the return request object. It first enters in drafting mode, which is where the customer is adding items to be returned. The request then moves to a submitted state, in which it's verified against the return policy. If the items are not allowed to be returned, then it goes to an invalid state. However, if the items are allowed, it goes to a state of pending approval, where the manager gets notified to review it. The request can then go to either approved or rejected state. For approved requests, the next state is fulfill, which represents the items have been received and the refund has to be processed. Finally, I have an archive state, which is just kept for historical purposes, like auditing. Next is object level sequence diagram. This is based on the previous diagram just with more details. The actor initiates first by getting into the system. We retrieve from the database the customer object and validates the credentials. We then get all the orders. By accessing them, going through the customer object, we need a loop for all the orders to retrieve each of their information. All the orders information is then returned back to the customer. He can then select a single order. So we have a search order method in order to retrieve the particular object order in an object named O, owned by the domain controller, and we get all the items in that order. At this point, the customer can create a return request. The system must retrieve the store object since it contains the return policy. The next loop represents a customer selecting each item and then being added to the return request. The last step here is when the customer submits it, and the system must validate each item against the return policy through this loop. We can now discuss the last use case. This describes the scenario when a manager approves a return request. The actor is the manager. The preconditions are the system being active, the manager has an account already, and there are at least one request pending. The expected post-condition is that the return request is approved, and the business rule is that the managers must approve or reject within 72 hours of being submitted. In the system sequence diagram, the manager logs into the system, displays all pending requests, and then selects a single request to approve it. After confirming, the system must process the return request for each item. For the class diagram, we have a store manager object that is associated to a store object and the return request. We also know that in order for a request to be acceptable, it needs to be evaluated against the return policy. Therefore, we have an association between the two of them. For the state diagram, I'm representing here the return policy object. Again, the initial state is in drafting or edit mode because it allows for items to be added to the policy. It will then move to a review state in which you cannot edit it anymore and is just waiting to be approved. There, objects can be returned to an edit mode or be accepted into a publish or active state, which means that this is the policy to be used to evaluate returns. If the policy is not valid anymore, it will move to a not active state, in which it can go back to edit if needed. Finally, there's a deleted state in which it is removed from the database. Now, let's discuss the object level sequence diagram. First steps, the manager logs in, and we get the store manager object from the database in order to authenticate the credential. The manager selects to be all pending requests. The system gets the store object and all the return requests from the database. Then we get only the pending request. We have a loop that goes through all of them to get the date and items. All the pending requests are returned to the manager. Then he can select to view one of them. So we have a search return request method. Finally, the manager approves the request, so we set the status of the object and save it to the database. This concludes our presentation for our group project. Thank you for listening.